Welcome to the Unreally Impressive Coder, where aspiring engineers transform into coding legends, ready to conquer their dream job interviews. Join me on this journey as we explore essential interview techniques, mastering data structures and algorithms to stand out from the competition. Together, we will dive deep into programming languages, ensuring you are fluent in the syntax and concepts that top tech companies demand. Prepare to tackle competitive programming challenges with confidence as we break down complex problems and devise winning strategies. With practical insights from platforms like LeetCode, HackerRank, and Codeforces, you'll sharpen your skills to excel in real-world coding interviews.
Welcome to this video. In this video, we're going to solve this coding interview question, reverse linked list. In this problem, we're given a singly linked list. We have to reverse the single linked list and we have to return the head of the reversed linked list. Let's assume we're given this linked list 1, 2, 3, 4. Actually, we're given the head of this linked list. We have to reverse this linked list and we have to return the head of reversed linked list. We have to reverse this linked list and we have to return the head of the reverse linked list. If we reverse this linked list, then we will get 4, 3, 2, then 1, then null. This is the reversed linked list of this given linked list and we have to return the head of this reversed linked list. This is the problem. If we are given a null linked list, we can return the null linked list. If we are given a linked list which is containing only one node, then we can return that linked list. This is the problem statement. Now, how we can solve this problem? In this video, we're going to talk about 4 different approaches. First, let's talk about the naive approach. In this problem, we are not allowed to copy the node. We have to solve this problem by manipulating the pointer only. We have to manipulate the pointer. We cannot create a new node. First, let's talk about the naive approach. The naive approach is not accepted in an interview settings. First, let's talk about that. Let's talk about the naive approach. In the naive approach, we'll create a stack data structure and we'll iterate this linked list from left to right, from head to tail, and we'll store the node onto the stack. First 1, then 2, then 3, then 4. Now what I can do, we can pop out the top element from stack and we can add it. So 4, then 3, then 2, then 1, and here null. We see we have reversed this linked list, but we're storing the linked list onto the stack, and then we're removing the top node from stack and we're just adding next to it. So this is our top, then 3, then 2, then 1. First we'll remove 4, we'll add 4, then 3, then 2, then 1. This is the naive approach to solve this problem. This algorithm will take O of n time complexity and O of n space complexity. But this solution is not accepted. We have to solve this problem by manipulating the pointer only. First, let's talk about the iterative approach. First, let's draw here a linked list. 1, 2, 3, 4, and 5. It's connected to null node. This is the tail. Now, let's see how to solve this problem iteratively. We'll have 3 pointer. Prep pointer will point to null node initially. Let's call it P for prep. Prep pointer will point to null node initially, and prep pointer will point to the head of our reversed linked list. Up until this point, the reversed linked list is null, and we'll initialize a current pointer to the head. This is the head of this linked list. So current pointer will point to this node 1, and we'll have a variable temp to keep track the next node of current, so we can access the next node. If we reverse this part, then we will lose the next node. We cannot access that. That way we have to keep track using a temp pointer. So let's assign a temp pointer to this node 2. So we have here prep pointer, current pointer, and temp pointer. Now what I'm going to do, I'm going to remove this link and I'm going to connect one to null. Then what I'm going to do, I'm going to move prep to current. I'm going to move prep to current, and then I'm going to move current to temp. So let's move it. Prep will point to this node and current will point to this node, and current will point to this node. We have to keep to the next node, so let's initialize a temp pointer to the next of current, so temp will point here. Now let's remove this node and let's connect to this prep, this current to prep. Now we're going to move prep to current, current to temp. So let's move it. Prep will point here, current will point here. Let's assign a temp pointer to the next of current to keep track the next node. Now let's connect current to prep, so it will be connected something like this. Now let's move prep to current and current to temp. So prep pointer will point to this node and current pointer will point to this node. Since we have connected 3 to 2, so this link will be disconnected. Now let's keep track the next using temp. So temp will point here. Now let's disconnect this. Let's connect it to prep. Let's move prep to current and current to temp. So prep will point here and current will point here. Let's keep to the next node. Next is null node. Now let's connect it, current to prep, and let's move prep to next and current to next. So prep will point here and current will point to this node. We have to remove this. When we find out current is pointing to null node, we'll stop. We'll return the prep pointer, the node at prep pointer, that is 5, and we see this is the head of our reversed linked list. So we get this linked list 5, 4, 3, 2, 1, then null. This is the iterative approach to solve this problem. This algorithm will take of n time complexity. We have to traverse every single node once, and it will take of 1 space complexity because we are using 3 variables, prep, current, and temp. This is our iterative approach. Now let's implement this algorithm. Now let's implement our algorithm. First, let's check the base case. If head equals to null, or if head.next equals to null, then we'll return the head. If we're given a null linked list, we have to return null. If you're given only one node in the linked list, we have to return the head of that linked list. This is the base case. Now let's create 2 pointer, current and prep. List node current equals to head. Current pointer initially points to head node, and let's create another pointer, list node prep. Prep will point to null. Prep will point to the head of our reversed linked list. Initially our reversed linked list is null. Now let's run a while loop while current is not equals to null. First let's find out the temp node. Temp equals to, temp is the next of current. If we don't store the next of current to this temp variable, we'll lose the value. So let's store here. So temp equals to current.next. Right below here, let's connect current.next to prep. Let's move prep to current, prep to current, and let's move current to temp. If current pointer points to null node, this loop will stop. We will return prep. Prep will point to the head of reversed linked list. This is the algorithm. This algorithm will take of n time complexity, and it will take of 1 space complexity, and it will take of 1 space complexity because we're using 3 variable, current, prep, and temp. We're not using any additional data structure, so it will take constant space complexity. Now let's run this algorithm. Accept it. Let's submit it. We have solved this problem iteratively. Now let's see how to solve this problem recursively. The solution a bit tricky. Let's see how to solve this problem recursively. We're going to reverse this linked list from right to left. First thing, what we're going to do, we're going to traverse the linked list from left to right. We're going to traverse this linked list by calling a recursive function, so we can access the node from the state of our recursive function call. First we'll call with 1, so we'll have in our stack 1. Then we'll have this node 2 in our stack. Then we have 3. When we find out, then we have 4. Now we'll call with this 5. But for this 5, we see that this is the last node. Whenever we found last node, we'll attach a new head pointer. Let's call it nh for new head. We'll attach a new head pointer to the last node and we'll return this node. We'll attach another pointer here, temp. Let's call it temp. We'll attach a temp pointer here. So for the last function call with this node 5, we'll attach a new pointer. We'll attach a new head pointer because this is the last node. Since we have returned this node, so we'll insert another pointer temp. We're attaching this pointer new head for the last node. Now from our recursive call stack, we have this node 4. So in our current function call, we have the access to this node with the parameter. If you call the function, if you call a reverse function with a head, then we'll have the access of this node with this head parameter. Now here what I'm going to do, I'm going to apply a formula temp.next equals to head and head.next equals to null. So temp.next equals to head and head.next equals to null. Next equals to null. We will apply this formula temp.next equals to head and head.next equals to null, and we'll return the head node to the previous recursive function call. So here if we connect this 5 to 4 and if we disconnect this link, we will attach this to null node, so it will be disconnected. We will have something like this. Now we'll return this node, so we'll attach a temp pointer to this node 4. On our stack, now we have the top node 3. This is the head node. Now if we apply this formula, this is the head, temp.next equals to head. So let's connect it to this and let's remove this head.next equals to null. So let's remove it. Now we'll return this node 3. So we're done with our current function call. Now we have recursive function call for 2. Now we'll return 3. So we'll attach here a temp pointer. Temp will point to this node. This will be the head for our current function call. We have the recursive function call for 2. We're using the advantage of recursion to solve this problem. Now let's disconnect this link and let's connect it. Simply applying this formula, temp.next equals to head and head.next equals to null. Now we'll return this node 2. So we're done with our current recursive function call. So we'll attach here a temp pointer. We'll return 2. So we'll attach a temp pointer to the returned node. This is the head node we have access. This is our current function call. So here we'll point here. Now we're gonna disconnect this. We're gonna connect here. Now we'll return this node 1. So we'll attach a temp pointer here. So temp pointer is pointing to this node with the recursive function call with this node 1. Now we have empty stack, so we're done. We'll just return this new head. This is the recursive algorithm to reverse a linked list. This algorithm will take of n time complexity, and also it will take of n space complexity for this recursive call stack. We know recursion uses stack internally, so it will take of n space complexity for the stack data structure. Now let's implement this algorithm. First we have to check the base case if head equals to null, if we are given a null linked list, or if we are given a linked list with one node, we have to return that linked list. So head.next equals to null. In this case, we'll return the head. Now let's create a global variable here, list node new head equals to null. This new head will point to the head of reversed linked list. Now here we'll call a function recursive function reverse with the head of given linked list. This function will reverse the linked list and it will attach this new head to the head of reversed linked list. Here we will return the new head. New head will point to the head of reversed linked list. Now here let's implement this function reverse private list node reverse list node head. It takes one parameter head. We have a base case here if head dot next equals to null. If we find out the last node, what we will do, we will attach this new head to the last node. New head to the last node, new head equals to head, and we'll return the head. Here let's call the function recursively list node temp equals to reverse. Now here we're going to call this function reverse with head dot next. We're just moving from the head node to the tail node. If we find out tail node, we will return the tail node and we will assign new head to the tail node. The tail will be the head of reversed linked list. And here we have access to head node, so we can say temp.next equals to head. Now we have to remove the link from head.next to null. Okay, let's take an example here. 1, 2, 3, 4. New head will point to 4 and this function reverse function will return 4. So temp equals to 4 and we have head equals to 3 from the recursion function call. If we say here temp.next equals to head, so it will be connected something like this from 4 to 3 and we have to remove the link from 3 to 4. So if we say here null, it will be removed. So we reversed this part and we will return this head 3. Now here this 3 will be the temp and this will be the head. So we will attach a new pointer from 3 to 2 and we'll disconnect this. Then we'll return this 2. This 2 will be the temp and this one will be the head. So we'll connect it something like this, temp.next equals to head, and we'll remove head.next equals to, so head.next equals to null. So it will be removed and it will point to null. So if we return this new head, we will get this linked list in reverse order 4, 3, 2, 1 now. This is the algorithm. And here we have to return the head. So return head. This algorithm will takes of n time complexity and it will takes of n space complexity for the recursion call stack. Now let's run this code. Accepted. Let's submit it. We solved this problem. This is the algorithm. This is the implementation of this algorithm. Let's see another recursive solution for this problem. Now let's see another recursive algorithm to reverse a single linked list. This is the head of our given linked list. We'll call a recursive function with this head and with the head of reversed linked list. Initially, our reversed linked list is null. This is the reversed linked list initially. Now we're going to call a function with the head of reversed linked list and with the head of our given linked list. This is the head of our given linked list. Now what we're going to do, we're going to access the next node of our head node. So head will point here and this is the head of our reversed linked list. Let's call it new head, nh for new head. First we'll reverse this two node, new head and head. So we have to keep track the next node, otherwise we'll lose the access to the next node. So let's attach a pointer here. Let's call it next. This is the next node. So we attach a next pointer here. N for next, A is for head, N is for new head. Now what I'm gonna do, I'm gonna just remove this link and I'm gonna connect it to this node. We'll apply this formula. head dot next equals to the new head in H. Now we see the head of our reversed linked list is this. So we'll call a recursive function again with the new head, this head, and with the head of our linked list is this node too. So this is our new head for our next recursive function call, and this is the head of our given linked list. Now this is the head. The actual head was 1, but let's assume this is the head for our linked list. So we have this connected part, this is the head of this part, and this is the head of this part. This is the new head and this is the head. Now let's keep track the next node so we can access the next node with this next pointer. Now what I'm going to do, I'm going to apply this formula. Let's disconnect, let's connect it. Now we see that this head is our new head and this next is our head for our this portion of this linked list. So this is the new head and this is the head. Now let's keep to the next node. Let's remove this link and let's connect to this node. Now we see that this is our head and this is our new head. So let's move them. New head is the head of our reversed linked list and head is the head of our linked list for this portion of this linked list. Now let's keep to the next node. This is our next node. Let's remove this link and let's connect here. Now we see this is the head of our reversed linked list. So this is the head of our reversed linked list and this is the head of our, this is new head and this is head. Let's keep to the next node. Let's disconnect it. Let's connect to new head. Now we see this is the head of our reversed linked list. So in H, new head, and this is the head. When you find out head is pointing to null node, it means that we have reversed the entire linked list. We are done. We'll return this head. We see that this is the head of our reversed linked list. So we have reversed this linked list 5, 4, 3, 2, 1 null. This is our algorithm to reverse a linked list. This algorithm will take big of in time complexity and it will take big of in space complexity for the recursive call stack. Hope you have understood this algorithm. Now let's implement this algorithm. Let's implement our algorithm. First, let's check the base case. If we're given a null linked list, we'll return that linked list. If we're given a linked list with one node, we'll return that linked list. So head.next equals to null, we'll return that linked list, return head. Now here I'm going to call a function reverse. Let's call a function reverse with two parameter, head and null. So here head is the head of our linked list and the null is the new head. New head is the head of our reversed linked list and this head is the head of our given linked list. We'll reverse this linked list using this function and we'll return the new head. New head will point to the head of our reversed linked list. Now let's implement this function. Private list node, the return type list node, reverse, it takes two parameter, list node head and list node new head. Now let's check here base case. If we find out head equals to null, then what we will do, we'll return the new head. Return new head. It means that if head points to null, it means that we have reversed the entire linked list. Just return the head of our reversed linked list, that is new head. Now let's reverse our linked list. We'll reverse from left to right. If we have 1, 2, 3, 4, first what we will do, we'll reverse this 2. We'll have here null actually on the left of 1, null. First we'll reverse, first our new head is null. Now we'll reverse this, it will become something like this and this will be our new head and our head will be 2. So initially this is our new head and this is our head. We'll reverse this, we'll get here something like this, then This is our new head and this is our head. So let's reverse it. Then this is our new head, this is our head. Let's reverse it. This is our new head, this is our head. Let's reverse it. Then our head will point to null. Head will point to null, so we'll return the new head. This will be the new head. This is how this algorithm works. Let's implement it. Now here what I'm going to do, I'm going to store the next node of head to a variable, otherwise we'll lose the next node of head. So list node next equals to head dot next. Now what I'm going to do, I'm going to reverse our pair. So head dot next equals to new head. Now I'm going to call this function recursively. So if we have something like this 1 2 3 and we have null, first what we will do here, we'll store this will be the next, this 2 is next, and this is our head and this is our new head. So we'll reverse this part. Head dot next equals to new head. It will be something like this. So this will be disconnected, and then we'll call with this new head and this head. So let's call this function reverse with next. Next is our head and head. This head, we have access to this parameter for our current recursive call, and we'll return. When our head becomes null, we'll return our new head, and we'll return the new head to this function call, and we'll return the new head to this function call. This is the algorithm. This algorithm will take of n time complexity, and it will take of n space complexity for the recursion call stack. Now let's run this code. Accepted. Let's submit it. Accepted. This is the implementation of this algorithm. Hope you have understood 3 algorithms to reverse a linked list. Thanks for watching this video.
Hey there, unreally impressive coders. Thanks for tuning in today. I hope you found our coding adventures fruitful and insightful. Don't forget to subscribe and hit the bell icon so you won't miss out on our future content packed with in-depth programming tutorials, crucial DSA preparation, and tips for nailing those top-tier company interviews. We cover a wide range of topics here, from engaging and competitive programming challenges on platforms like LeetCode, HackerRank, Codeforces, and CodeChef, to diving deep into AI and machine learning. Whether you're sharpening your skills or learning something new, we're here to elevate your coding expertise. Share your thoughts or questions in the comments below. I love hearing from you. Let's keep this coding community thriving. Thanks again for your support, and remember, practice makes progress. Stay tuned, stay coding, and stay impressive. Catch you in the next video.